My name is Lynn Billman. You got my name on your screen, I think. Most of you know me. I know most of you. And our speaker tonight is going to be Andy Fletcher. Andy, wave, please. There's what Andy, okay. I'll tell you about Andy in just a minute, but first of all, let me tell you how we're going to do this. Andy's going to take over very quickly here, and he has a presentation. I told him 30 minutes, 45 minutes, whatever he feels like is necessary on chaos theory, short and sweet. And while that's going on, if you have questions, please use the chat feature at the bottom of your screen. And if you would just address the chat to me, then I can sort of capture them without distracting the other people who are watching. And then I'll feed the questions to Andy at the end of his talk, and we can have our discussion that way. And after the questions are pretty well taken care of, if you would like to hang on for a few minutes, we'd like to kind of spend some time just chatting with each other, especially if you're new. Where are you at? What city are you in? What is your interest in faith and science? Your connection with ASA? We'll do a little bit of this get to know you stuff after each of the monthly virtual events, and we might get to know each other a little bit more as human beings. So,
Lynn?
Yes.
Yeah, that sounds great, but I'll have to beg off because those of us in Eastern time zones here, why it's
9 o'clock, yeah.
quickly be past our bedtime. So,
Well, we appreciate you staying up a little later for the talk, Randy. That's great.
at some stage, I'll slip away.
Okay.
But, just to
understand. If I think you're all either ASA members or you're on my friend's email list. If you're not, Stan, I can't remember whether you are on my list or not. If you're not, and you'd like to get the updates from me, well, you'll get everything through the ASA membership emails. But if you're not an ASA member, send me your email and I'll put you on the list also. What else do I have to say?
Lynn, you should know I took the liberty to invite everybody who came to the prayer meeting today.
Sure.
To our event tonight. I figured we could call it part of the ASA annual meeting week. So I know Stan was at that meeting, so I don't know if he came as a result of that invitation or not.
Well, that's great. Thank you very much, Terry. Appreciate that. All right, so let me introduce Andy Fletcher. Andy's an ASA member from Colorado Springs, and we are fortunate he is quite an author of books and articles and a professional speaker on science topics and faith and science topics. He has spoken thousands of talks in 43 countries, as he says. I know, Andy, you talk a lot to IB students, International Baccalaureate students, and to adult groups of all different kinds. When I was first getting to know Andy a little bit, he had taken a paying gig to give kind of popular science talks on a large cruise ship that was going around the world in early March. If you think back to early March, being on a cruise ship was not a good thing. Now, he finally did get home safe and sound. So that's another tale of its own. But Andy, I want to turn it over to you on chaos theory, short and sweet.
All righty. Thank you, Len. Thank you, everybody, for showing up. I'm always grateful if anybody shows up. That's you set the bar low and then you always exceed it. The secret to a happy life is low expectations. That's my life mantra, and it seems to work out. The name of my organization is Life, the Universe, and Everything. And as Lynn has said, I talk to mostly high school students and IB schools around the world on a variety of topics: relativity, quantum mechanics, chaos, complexity, being the kind of the four main topics, with an eye towards introducing the concept that God might exist in all of the midst of this. There will be chaos is not the talk where God appears in quite as dramatic a fashion as he might in some of the other places, but God is a God not just of order, but of chaos in a creative way, and we will see how that plays itself out as we go along. So, Lynn, I think you were going to say if they have questions, they can type them in the chat, and then you'll relay them to me, or they can ask them themselves once we get to that point. So, love to hear your questions. Oddly enough, where relativity and quantum mechanics generate a lot of questions, chaos is something that we haven't considered always in the fullest of its ramifications. But once you hear them, there aren't that many questions. You kind of go, oh yeah, I know how that works, because, you know, not to put too fine a point of it, that's where we're living right now, is in the midst of chaos as a planet. And we'll talk about that a little bit as well. I probably have more material. I have a lot of stuff that I've blacked out. I'm going to apologize for eliminating most of the humor. And part of that is in the interest of time. And part of it is because humor in a Zoom talk is really a risky thing. You can't ever hear anybody or see anybody laughing, and you just don't know how it works. And it's like doing stand-up in an empty room. It just doesn't seem to work quite as well. So, yeah, I did a talk for a school in Switzerland a couple of weeks ago, except of course the teacher was in Munich, the kids were in China, Russia, Brazil, the United States, Switzerland, Europe, and Canada, even though the school was in Switzerland. And I left the humor in, and it just, you know, you kind of have to say, okay, this is a joke. And that's just not the way to tell a joke. That just doesn't work. So here's what I'm going to do is share the screen and start the keynotes. If everything works according to plan, then we'll be in good shape. All righty, everybody see everything okay?
Yes.
Okay, I'm gonna make you all go away so that I can see my screen. The talks that I do are called Life, the Universe, and Everything, which of course I stole from Douglas Adams without apology. And that's the name of my website. It keeps appearing in places with 2 E's between universe and everything. So if you really want to go there, you have to leave one of the E's out. lifeuniverseeverything.org, or you'll go someplace that doesn't exist. So let's dive into chaos. The Newtonian conceit, the Newtonian construct of the universe gave rise to 4 different ways of describing the world, both scientifically and sort of metaphysically and philosophically. I'm not going to talk about one of them tonight, which is mechanism, because chaos is the thing that deals directly with mechanism. So let me define, and I know that you know a lot of this already, but bear in mind that I'm used to talking to high school students, so I have to do a lot of definitions for them because this is all new to them. A mechanistic universe is a universe defined as being nothing more than a machine. You'll remember that Isaac Newton thought it was a clockwork mechanism that worked perfectly. And what it led to was a universe that is predictable. And I always tell my students that the essence of science is predictability. Without predictability, science is pretty useless. It's no more than an intellectual exercise. It is in its predictability that it allows us to make useful things. When you go down to start your car in the morning, you turn the key and the motor is supposed to go on. That has not happened with my car for the last couple of days, and so I can also predict that something is wrong with the battery. So my car's in the shop right now. Everything works like a machine. Nothing is random. Humans are nothing more than just intricate machines, which means that we are entirely 100% in the Newtonian construct predictable. Jacques Monod, the French Nobel Prize winning biologist, said it like this, only in French: anything can be reduced to simple, obvious mechanical interactions. The cell is a machine, the animal is a machine, man is a machine. So we have been reduced to being nothing more than mechanical interactions. Now chaos comes along and will be more than a little challenge to that. It's fun, again, as I said to you last time, I think it's fun talking to you guys who are around and aware and cognizant in the year 2000. The high school students that I'm talking to these days were not. They weren't there for 2001. And so this is all history to them. It's not history to you. This obviously is a Newsweek cover with the word chaos across the middle. And it was all about the election in the year 2000 when it came down to some hanging chads, about 576 votes or something like that, 567 in a county in Florida that couldn't be counted. Normally, what would happen, of course, in any kind of an election is that one person would win and another person would lose, the winner by a large margin of votes. But in this election, the margin of votes in Florida was very, very small. The margin of votes in the Electoral College was very, very small. And so it turns out that in this instant, those 500 and some odd votes actually were going to define for us who the next president was going to be and determine in ways that we could not yet imagine what the course of historical events was going to be. As we remember, they couldn't count the Chads. It went to the Florida State Supreme Court or the Attorney General, Catherine somebody, who decided that she was going to give Florida to Bush. It went to the US Supreme Court, and by one vote, they gave the election to Bush, and history was set in its path. That's how chaos works. That's a great example of chaos. Chaos is not a great big mess. Chaos is not things just falling apart. Chaos is very, very specific, and it is specific in this way, that the universe is really all about radical unpredictability. It's a complete and total challenge to the Newtonian construct of the universe, where everything is mechanical, predictable, and completely random, or not random. Chaos theory tells us, or suggests to us, if you like, at this point, until we see some evidence, that the universe is all about radical unpredictability, where every now and then there will be a very, very delicately balanced set of circumstances where something is going to happen that's very, very small, that sets off a large sequence of events, an avalanche, a collapse, a dominoing effect, where something very, very major is changed by something very, very minor. In the case in Florida with the election, it was about 500 tiny little bits of paper, and nobody could tell who was supposed to have been chosen as the candidate, as the choice for that person. And so it cast the whole thing into chaos. Strange attractors, I'm going to take a minute and talk about those. We don't have in chaos theory specific answers, but we do have a range of possible answers in very intriguing sorts of ways. We have nonlinear systems as opposed to linear systems. The butterfly effect is really what we're talking about, where something as small as the flapping of a butterfly's wings will set off this cascade, this avalanche, this systemic collapse, and result in something very, very large, very unexpected, and most interestingly, very, very unpredictably, that you could not predict what the outcome was going to be based upon your starting point, that it sends the whole system into radical unpredictability. It applies to weather systems and economics and really every aspect of science and life. And if we had time, as I sometimes do, I would ask you each for an example in your life where some tiny thing had kicked off your life into a direction that was unexpected and possibly unplanned and possibly unwelcomed, but certainly not anything you could have predicted. Here are strange attractors. This is a graph of possible answers in a nonlinear system. Not a linear graph, not something that you would just see on a coordinate plane, but kind of a mess. And in fact, it's three-dimensional. And you can see this being a little more three-dimensional as a strange attractor. And this, in fact, as we said, it's spinning, really gives you a sense of how the graph is not in a plane, but it is in fact in space. It's a three-dimensional range of answers. And the reason they call it a strange attractor, I think, is because things are attracted to this locus of points, but in an unpredictable way, in a chaotic, but capital C, with chaotic unpredictability. We're not going to spend any more time with those. They're fun to look at, fun to investigate. It gives you a sense of where we might be going. I'm going to throw out several right here at the beginning. This is a new slide. I haven't done this before. Several different places where chaos is sort of ruling the roost. Chaos is reigning supreme. And I'll tell you how they are chaotic one by one. Some of them we're going to unpack in a little more detail. Others we won't have time to do. Climate change, the way that you define climate change in the sense of being chaotic is that you have a 1% of 1% change in the composition of the Earth's atmosphere in carbon, and it has led to a 1 degree change in the average temperature of the Earth's oceans, and it has set off this cascade of events that are going to be a lot more dramatic in the long run than COVID-19 right now is being in the short run. COVID-19 is next, and we will talk about that. Basically, a guy eats a bad bat in Wuhan and the entire world is changed. All of our lives are changed. We're experiencing that change right now as we do this on Zoom instead of face-to-face. And I have a long list of things that I've been collecting about how COVID-19 has had an impact on the world. George Floyd, there have been a lot of, sadly and tragically, a lot of black men who've been killed who were innocent over the years or certainly did not deserve to die. But because of COVID-19, the killing of George Floyd has set off this, again, avalanche of protests and riots and change that I believe would not be happening if it weren't for the fact that we were all isolated and not working at home because of COVID-19. So those things are interrelated in a chaotic sort of way. Arab Spring, we won't take much time to talk about. It's really fascinating. A fruit vendor in Tunisia was upset over the way the government was treating him, set himself on fire, self-immolated, and set off a collapse across the Middle East that is still going on. In all of the countries, there have been changes, and it is still a mess in places like Yemen right now, and Lebanon, and Egypt, and in other places. Leaders were driven from power and in some places killed, all because of a fruit vendor in Tunisia upset over the way that he was being treated. And everything just lined up in exactly the right way to cause that sort of systemic collapse, the butterfly effect coming into play. World War I and World War II, another interesting story we won't have time to talk about tonight, but there was an assassin who was trying to assassinate the Archduke and knew which way his caravan of cars was going to go. He got held up. I don't remember why, some accidental little thing that held him up, and he missed his moment. The Archduke was already passed when he got to the place where he had planned to kill him. And so, disconsolate and upset, he wandered off and just happened to wander across the cars again and went ahead and assassinated the Archduke, set off World War I. Without World War I, there very likely would have been no World War II. And so it was a tiny little event that kicked those things off because of all of the circumstances that were lined up together to fall apart in exactly the right or the wrong way, depending upon how you want to talk about it. 9/11, we'll take a few minutes to talk about that later. You've got 19 guys with little bitty knives, changed the history of the United States, changed history for many parts of the world, an impact that still goes on and will go on probably for a while longer. We'll talk about that a little bit later. The space shuttle disasters we will talk about, not even going to go into it right now, but both of the space shuttle crashes were caused by tiny, tiny little failures of things that had worked the way that they had worked many times before. But a confluence of events caused the disasters to happen. And as we just talked about, the 2000 presidential election was changed by tiny little bits of paper, little hanging chads and all that kind of stuff, changed American history and the history of the Middle East and in some ways maybe the history of the entire world. All right, a little bit of, that's kind of an introduction. Let's do a little bit of history, just for a moment. In 1961, Ed Lorenz at MIT was trying to use computers to predict the weather. This was computers in 1961. Those of you who are into computing in 1961, even those of you who are not, know what we're talking about. Massive, great computers that don't have the computing power of the Apple remote that you use on your Apple TV. But he had a vision. He wanted to try to predict the weather. Be great for everybody to know what the weather was, great for the farmers, great for the tourist industry, and great for Ed Lorenz because he'd make a lot of money. And so he was programming computers to predict the weather. And here's the text of what happened. This is the previous picture was the actual graphs. This is kind of a mock-up so we can see what happened. And you could look at the first run where he put in all of his values and he predicted rain. Of course, as a scientist, you don't do it just one time, you do it many, many times. So put all of his values in again. Second run predicted sunshine, completely different prediction. And what they discovered was that the computer, as you can see in the text right there, was keeping track of numbers to 6 decimal places, but the printer had rounded them to only the first 3. So you got the hundreds, the tens, the hundreds, and the thousands covered, but from the 10,000s on, the errors began to kick in and take the weather prediction in an entirely different direction. And so most of us would have probably, I know I would have said, well, you know, I'm going to have to go back and do that and not round those off. But what Ed Lorenz had was an epiphany, a realization that somehow a 10,000th of a degree variation in temperature or barometric pressure was enough to change weather patterns over the long run, even though the change was felt just very much in the short run. Things have gotten better since 1961. As this says here, a 5-day forecast now is as accurate as a 1-day forecast in 1980. Useful forecast 9 to 10 days in the future. But here's the chaos sentence that we need to recognize as taking us in the right direction. Sensitivity to initial conditions limits long-term forecast skill. Details of weather cannot be predicted accurately, even in principle, much beyond 2 weeks. So that's taking us in the direction that we need to go. And there's your 5-day forecast. Sorry, I didn't take that cartoon out. I left that one in. So things are a little bit better now than they used to be, except in Colorado, as well you know, since you live here, that's very much, that's not just a 5-day forecast, that's a 5-hour forecast in Colorado because of the place that we live and the circumstances. So here's what we've got. Let me define it for you a little bit. It's bad keynote technique to read. I'll read a little bit every now and then. As you might expect, when you vary the initial conditions, you can get very different results. Small differences lead to large ones over time, and that is the butterfly effect. That's chaos theory. Known about this chaotic systems for decades, ever since 1961, but the team found that the tiniest shifts can lead to big variations. And this is what I find really interesting because I do a lot of talking about quantum mechanics. When they made the shifts as small as a Planck length, that's misspelled as a word, most of the simulations remained really consistent, but about 5% of them still varied widely. This is interesting because a Planck length, again misspelled, I'm going to have to find out what magazine this came from and complain. It's interesting because a Planck length is about the limit of scale for quantum systems. Smaller than that, and the known laws of physics break down. A Planck length is the length of time that is the distance that time travels in a, and I forget what it is, a very small amount of time. Somebody's going to have, so one of you physicists tell me how much that is, but it's a very small amount of time. So the known laws of physics break down. So we can't always predict the future. What else is new? But since the laws of gravity are time reversible, this also means that for some systems, we can't know their origin, not even in principle. And so what that means is that some of the time, we're not even going to be able to backwards engineer things to figure out why what happened actually happened. And go back up to that first paragraph. Most of the simulations were consistent, but about 5% of them still varied widely. And again, that's a great explanation of chaos. Some of the time, chaotic systems kick in. and make things happen. Most of the times things are predictable, and they're supposed to be, otherwise we'd have no ability to have any science at all. So most of the time predictability holds true, but there are critical times when predictability falls wildly short, as we will see. The rest of this is pretty much examples about what happens when chaos kicks in. This again is a new slide. A bizarre snow strip over Kansas, just 15 miles across, highlights the challenges of forecasting. More than a foot of snow fell in the band, which is only 10 to 15 miles wide at times. Just a few miles on either side, there were hardly flurries. Meteorologists have long vented about the challenges of prediction when it comes to difficult winter storm forecast. And again, we live in Colorado, we know all about that. But the razor sharp nature of Tuesday's hyper-local snow band was a step beyond what most Great Plains forecasters are accustomed to. Significant amount of slide-offs and wrecks were reported with visibilities below 200 feet, just in that little band of snow that somebody took a picture of from an airplane, just to illustrate how radical that was. One such band brought 88 inches of snow to parts of Erie County, New York, 2014, 5 feet of snow east of Buffalo, 2 days in November. Several feet of snow fell at the intersection of Transit Road and Walden Avenue in Depew, while Genesee Street, 2 miles to the north, so only a couple of inches. Yeah, we laugh at this as Colorado folks. We're like, so what else is new? You know, you drive down to Academy, they got 4 feet of hail on the road, and I got nothing on my house. That just happens all the time. That's just the norm. But there are no Great Lakes out in Kansas. Instead, the atmosphere simply must have been feeling a bit fickle. And there again is that attempt to go back and backwards engineer it and not being able to figure out why it happened. It is just one of those things that happens unpredictably. It is not something that you can forecast. Everybody gets very upset. What I've noticed about weather forecasting, as I've been watching this as a guy that likes chaos, is that the weather forecasters have started to predict the worst case most of the time. And then if it doesn't turn out that bad, then we say, oh, well, they just missed it this time. But if they predict something less than the worst case and all of a sudden something terrible happens, oh, then people jump up and down and scream, because the weather never ceases to amaze. And so there you go. That's an example. More examples. I've got probably too many hurricane examples going on in here, but I like them a lot. And they're hurricanes that you will recognize. This is Hurricane Harvey in 2017 that slammed into Houston. I've got a brother and sister-in-law that live in Houston. And what I want to train you to do, as I train my high school students, is to watch for the chaos language in all of these articles that I have snagged out of magazines and newspapers. Even in the 2 days before Harvey hit land, forecasters were unknowingly lowballing its likely impact. Just 2 days before it got there, they had no idea what was going to happen. Predicted to reach Cat 1 or 2, it smashed into the coast as a Category 4. Supposed to have 25 inches. They have over 50 inches, 52, I think. It was supposed to do what hurricanes do, which is to keep on going. Go inland, and it gets weaker and weaker and turns into rain, finally fizzles out. But Harvey stuck over Houston, drank the Gulf, dumped all of the rain on Houston, beyond anything experienced before. It was absolutely stunning. All right, I got a little bit ahead of myself here. This is Hurricane Katrina heading in towards New Orleans. And we all remember Katrina. Of course, now I have kids in classes that don't remember Katrina at all, but we all remember it. And what happened was Katrina was heading straight for New Orleans. The eye of the hurricane is where all of the damage gets done, so where the winds are the strongest. And the eye was heading right smack dab for New Orleans. At the last minute, the eye shifted off to the east and went through a little town called Waveland, Mississippi. And I have a friend who lives in Colorado Springs now who was teaching near Waveland at that time. So I think half of his students lost their homes. So I'm gonna show you some pictures of what happened to Waveland. These are before and after shots. When I'm trying to be funny, I'll say there are subtle differences here. See if you can figure out what they are. But I don't need to say that. Here's before and after. Couple of pretty good sized houses, and they are gone. They're not just blown down into rubble. It's like they sailed off through the sky to Kansas with Toto and Dorothy. Just completely gone. Here's a bigger house that is completely gone. Here's a little fish market. The market's gone. You can see the blue walls there and a chair that apparently blew in from Cuba. Everything is gone where the eye of Katrina landed, made landfall. Now this is a picture of New Orleans after Hurricane Katrina, which is pretty dramatic. But as you look at the picture, what you're going to notice is that all of the houses and buildings are still there. Not only are they still there, but they still have their rooftops. Now at the bottom of the picture, you can see about 3 or 4 trees that are blown down. But none of the houses are blown down. None of the buildings lost their rooftops. Everything is underwater. And so what happened with Katrina was not really so much the hurricane doing damage to the city, was that the levees collapsed. They were old, poorly engineered, and they collapsed. Lake Pontchartrain flowed into the 9th Ward, and people were drowning in their homes. And it was one of the largest city disasters, certainly in American history, and even around the world. The question is, what happened? And the answer is a chaos answer. And this is out of a newspaper someplace, probably the Post or the Gazette. It could have been worse. Devastating as it was, would have been far worse. And here's the chaos language. But for a puff of dry air that came out of the Midwest, there that is. That's the flapping of a butterfly's wing. A puff of dry air weakened the hurricane just before it reached land, pushed it slightly to the east, took it from Category 5 down to Category 4, pushed it away from New Orleans, sparing it a direct hit, though not horrendous harm. But again, the harm was because of the lake, not because of the wind and the rain. And here's what hurricane scientists say all the time. It was kind of an amazing sequence of events, which is to say, we blew it again. It did not match our predictions, and it was a whole lot worse than we ever thought it was going to be. On Sunday, they watched one of the most powerful hurricanes they'd ever seen, straight for New Orleans, Category 5, 175-mile-an-hour winds, 4th most powerful hurricane ever observed. But because of that puff of dry air out of the Midwest, it was no stronger than any of a dozen or more hurricanes that have hit the U.S. in the past century. All right, here's Hurricane Dorian hitting the Bahamas, and you'll see the chaos language even in the headline from the paper, why Hurricane Dorian defied forecast and sank the Bahamas. If you look at what the storm was predicted to be a week ago versus what it is today, I don't think anyone could have seen this significant a change. Dunyan, scientist, meteorologist, said he was surprised at how fast Dorian grew from Cat 4 to Cat 5. Usually you don't see rapid intensification in just one day. Usually happens to weaker storms. We went from Cat 4 to Cat 5 in just a few hours. That was something that doesn't happen very often. Weather systems hundreds of miles away have been changing the track of the hurricane, and that is something that's very hard to predict. Even small disturbances can trigger catastrophic storms. Here again, chaos language in the headline. After decades of research, meteorologists still have questions about how they develop. They found that even the smallest changes in atmospheric conditions could trigger a hurricane. Simulations started with mostly uniform conditions spread across an imaginary box where the model played out. They added a tiny amount of random temperature fluctuations to kickstart the model, observed how the simulated clouds evolved, and even the smallest changes could kick off a hurricane in an unpredictable sort of way. This is, again, I jumped ahead one. This is Hurricane Ivan or Ivy or something, not one we'll remember, but it went across Florida into the Gulf. And my brother who lives in Houston worked for an oil company. They had, it's Anadarko, they have oil drilling platforms off in the Gulf. And so these are pictures that he sent me that went around his company after this hurricane went through the Gulf. They didn't make the papers, so these were all in-house. So this is pictures taken at one point. Seemed like probably a really good idea to leave, but leaving was not going to be any fun. And you can see as they had to get on the little red tugboat that they had quite an exciting time getting to land. And when they came back after the storm had passed, it looked as though a giant had stepped on the platform, which is not too surprising. You could wonder why the right platform had no damage and the left platform was so structurally damaged, really probably ruined and needing to be replaced. You'd say, well, there's a little kink right there, a little rust or something. But the real story is that when they got up on the platforms to investigate the damage, they found something. It's 100 miles offshore in the Gulf of Mexico. They found something they did not expect to find all over the oil platforms. And it was great big piles of great big nasty snakes, cottonmouths, water moccasins, copperheads, all of them poisonous, all of them big. If you remember that scene in the Indiana Jones movie where he falls down into the snake pit and they were all around him writhing, they were, my brother said he had a picture of that he couldn't find. It was just a great big pit of writhing snakes. The question was then, of course, how do snakes of this size and danger get 100 miles offshore in the Gulf of Mexico? And you've got a couple of answers. One of them is the storm surge sucked them out. The other one is that the water spouts sucked them up into the air, carried them offshore, and dropped them out of the sky. Now, that is not my favorite thought, is snakes of this size falling out of the sky.
Wow.
And then, of course, you make a movie and you call it Snake NATO, and there you go. But this is a real life story of something that did not make the newspaper, of the unpredictability of hurricanes. Living in Colorado, I don't often show this slide. I do many times when I'm in Colorado, because it's a series of pictures of an avalanche with the photographer here at the end who stood a little bit too close taking the picture. And we can watch that again just for fun. The question is, what causes an avalanche? Exactly how much snow do you have to have, and what's the steepness of the slope and all the rest of it? And the answer is a chaos answer from Wired Magazine. If you're not reading Wired Magazine, you need to. It's my favorite magazine. And here's what the writer says. And I love the way he wrote this. This is a magazine that is clever and well written. It makes me want to stay off a mountain with snow on it. Any snowy slope steeper than 35 degrees has the stability of a fleet of 18-wheelers suspended by fishing line over a layer of bowling balls. An ounce too much pressure in the wrong spot at the wrong moment, and the whole thing comes down. Now that's chaos. No way to know when and where it's going to come down. And then this part is great for all of the scientists in the room. Snow is just so complex in terms of the processes affecting its structure. When I worked on the Apollo space program, I thought rocket science was the hardest form of physics, but snow science is even harder. We always knew, and here's chaos, we always knew tiny differences in weather make huge differences in snowpack stability, but we could never pinpoint what happened. Now we can actually see the bonds changing between individual grains. So there you go. The most complicated science known to man is snow science, apparently. That's kind of fun. All right. Again, weather. Weather being one of those places where chaos seems to kick in more often than in many other areas. Back in 2003, you can see the date on the bottom there, the eastern seaboard of the United States underwent the largest blackout in North American history up to that time. And this is a picture that some kid made on his computer and sent around the internet saying, look at the blackout. That was not the blackout. That was his thumb or something that he stuck in the picture. But these are National Geosat pictures of the area. And down in the bottom of the picture, you can see Long Island sticking off to the east. And then, of course, attached to Manhattan, and there's Pennsylvania, and there's New York, and there's Connecticut. There's that band of cities right across central New York. And then you look up into Canada, and you can see 2 or 3 large cities up there, and then some smaller towns. Between 1 second and the next, the lights went out. Long Island almost completely blacked out, large parts of Manhattan, even in Canada, all the way across New York, Connecticut, Pennsylvania. Some places not affected, others were. So the question was, what caused this? And the answer is that if you look over on the left side bottom of the picture there, you'll see a tiny little sliver of another state. That's Pennsylvania's the big state. Ohio is right next to it. And the answer is that one tree branch fell on one power line in Ohio. A tree branch, one power line, and set off this cascade of events. I thought I had some text there, but I don't, so I'll tell you what the story was. I was giving this talk one point to a group of adults, and a woman came up afterwards, and she told me that she was manning the computer center. She was the head of the computer center in the weather forecasting in Ohio at the time. They had old computers that took a long time to cycle from one picture to the next. And so they were all sitting around looking at their computers of one part of the state where everything was fine, and they completely missed what was going on in another part of the state. And by the time that the computers cycled over to that screen, the collapse had traveled all the way up through Canada, straight down through New York into Manhattan and Long Island, and they found themselves with more power than they knew what to do with, so they had to shut the entire thing down. And we got the largest blackout in North American history because of one tree branch and one power line. Same thing happened in Italy in 2000, about a month later. Just about a month later, we got a tree branch that hit actually one Swiss power line, chain reaction in Switzerland, moved through France. Tree branch hit, disabled a power transmission line, caused another Swiss line to overload, which then knocked out French transmission to Italy. One tree branch, one power line, and Italy was blacked out by the same sort of set of circumstances. All right, now you've been trained to be good chaos thinkers. How many lightning bolts does it take to change the stock market? It takes one. In this case, just one. Lightning destroyed the New Mexico chip maker that supplied a Swedish cell phone giant. Practically overnight, stocks for the whole market sector flip-flop. Market leader became a market loser. Global economies are connected. Stock market collapsed because of one lightning bolt in New Mexico, affected a company in Sweden. And there you go. The question, of course, then, which is the question that we now have that we can talk about more than once, is how long is the market going to be down? When is it going to come back up? How strongly is it going to come back? When are the effects going to dissipate? Chaos is going to happen. The question is, when is it all going to go away? And you know exactly what I'm saying. Here's some examples, and then we'll get into more specifics. Ecology and war. Small changes in climate can cause wars, topple governments, and crush economies already strained by poverty, corruption, and ethnic conflict. So you can see how all of the dominoes are set up there. You just push over one domino. Flooding, droughts, heat, hurricanes, whatever it happens to be, can send the country over the edge because it was so close to the edge already. Even a minor shock to the system can cause an enormous change in outcome, a nonlinear response called abrupt climate change. Seemingly modest fluctuations in rainfall, temperature, and other weather factors can create havoc in vulnerable societies. In Darfur, Sudan, drought caused a famine, caused a war. In El Nino in 1998, the government of Ecuador collapsed. President Suharto in Indonesia was ousted as a result of a weather system in the Pacific, which kind of makes no sense, but there you go. Everything is linked in strange, nonlinear sorts of ways. this is fun, and I'm going to go through it kind of quickly. Y2K was a great example of chaos, and I had been talking about chaos for a while at that point, and so I put this in. Of course, hardly anybody remembers Y2K anymore because we didn't actually go to Armageddon, but there was a reason for that. Why did Y2K happen? It's because programmers used 00 instead of 2000 or 1900. So when computers were going to roll over from December 31st, 1991 to January 1st, 2000, the thought was that the whole system would collapse. Computers would think it was 1900, cars would disappear, horses would come back, toilets would go away. It's going to be just a terrible, terrible thing. Millions of lines coded needed to be searched, and it was way too expensive to pay American computer programmers to search through the code. So they looked around for some place to find people who would do it. It wouldn't cost too much, and they went to India. India had an enormous English-speaking, highly educated labor force of computer programmers. Plus, there were cross-Atlantic, transatlantic lines, cable, whatever those lines are called that are made of glass. Tell me later. And so we could get the information back and forth. So Indians rewrote all our code and saved us from Armageddon. And then in 2001, when the tech market and the fiber optic cable companies collapsed and everything fell apart and we needed cheap labor to work on our computers, then we went back to India. We already knew that they were there. They were great at it, and they were cheap, and they worked hard, educated, English-speaking, willing to work. And so outsourcing kind of started because of Y2K. Outsourcing out of the country started because of programmers using 2 zeros to save space because memory was expensive instead of using the whole number. Chaos in history. 1965, massive power outage hits the Northeast US during rush hour. 30 million people into confusion. Traffic lights stopped and all the rest due to a single protective relay failure. That's when we began to use cascading failure in US government documents. 1984, wire service translation error caused a bank run on continental oil, leading to the then largest bank failure in US history. 1999, the largest power outage at that time hit Brazil. From March to June begins with a single lightning strike. 2010, in just 20 minutes, a single large sell order sends the New York Stock Exchange into its biggest free fall in decades, a flash crash causing the Dow Jones Index to lose almost 9% of its value. We would love for it to have just been 9% recently. 2012, 600, for still unknown reasons, can't backwards engineer this one. 670 million people in northern India lose power after a chain reaction caused by power trips, the largest chain reaction outage to date. Chaos, 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 chaos all over the place. Chaos in biology. I love this because all of my biology students at this point have started to lose interest, and so you grab them right back. Here's what we did. They decided they wanted to clone this cat. Cat's name was Rainbow. And here's what I tell the kids. You guys know this. High school students don't. So I asked them a question. I say, when you clone a cat, what do you get? And they say, you get the exact same cat. And I say, because? And they say, well, because DNA, they have exactly the same DNA, so you're going to get exactly the same cat. And I say, well, there you go. There's Rainbow. We took Rainbow's DNA, we cloned Rainbow, and we got this. Now, all the girls immediately go, oh, so, boys are too cool to do that. The girls, little cute kitty. And then they notice that the cats don't look alike. And then with the magic of modern technology, we'll grow Cece up into a large cat. And you can see that when you cloned Rainbow, what you got was an exact genetic duplicate that doesn't look anything like Rainbow. Rainbow is a calico with hazel eyes. Cece is gray and white with kind of grayish eyes. And then you got to tell the students, it's not just about the DNA. There's a complex protein epigenetic thing that goes on where things outside the genome have an impact on the way that the genome develops. And so you don't necessarily get the same thing. And there you go. Chaotic unpredictability, even in cloning. All right. Space shuttle disasters. This was the Challenger. Took off about 72 seconds later. It blew up, as we will all remember. I'm sure you remember where you were and what you were doing. I was teaching a high school class at the time. We were watching it on television. We saw all these pictures over and over again. I found a new picture the other day, this one right here, that where they actually thought they picked out where they thought the actual astronauts in the shuttle were. They were in the shuttle. My next door neighbor was the head of the propulsion team for the Challenger. They were alive all the way to the water, probably unconscious. So it was a huge disaster. Before it went up, I discovered not too long ago that a guy named Bob Ebeling, who was had joined 4 colleagues in trying to keep Challenger grounded. They argued for hours that the launch the next morning would be the coldest ever. The temperature was about 4 degrees Celsius, about 40 degrees Fahrenheit. It was not freezing, otherwise they wouldn't have gone. It was not 50 degrees, otherwise it wouldn't have been a problem. But the temperature was right on the edge of being dangerous. And so they put together, they wrote a paper. They said that it wasn't going to be a successful launch, that it was very, very dangerous. And the reason was that there were little tiny O-rings that have to be flexible. O-rings on every space shuttle. And because the temperature was cold enough, the O-rings were going to lose their flexibility. That was rejected. He went home that night and told his wife that it was going to blow up. And then, tragically and horribly, it did. Richard Feynman was on the commission to figure out what happened, and while everybody was sitting around arguing about it, Feynman took one of the O-rings and put it into his ice water, took it out again, and tried to squeeze it, and it had lost its elasticity at just about the temperature that it was on the launch pad at the time. And so that's what happened. The Columbia. Here's text that I have put in boldface there because it's chaos language. Cascading series of failures that destroyed the shuttle Columbia. And I have just recently, this was 80 seconds, you know, it's happened to 80 seconds. So the other one was 72 seconds, this was 80 seconds. But this one waited until reentry before, as you'll remember, before the disaster happened. Here's pictures that they took. You can see the foam. It's about a 1 kilo piece of foam. It's about 2.2 pounds. And it comes off, you've got insulating foam on the fuel tanks, and it always comes off. The shuttle, the rocket's going very, very fast. There's a lot of wind, a lot of shaking, a lot of heat. So the pieces of foam always come off. This one hit the leading edge of the wing on the left side of the shuttle, and they knew this had happened. And we'll talk about it in a minute, but here's what happened 16 days later as they tried to use the air blanket around the Earth to slow themselves down. The heat got in through tiny little cracks on the leading edge of that wing, melted the struts as a plasma inside the wing. The wing disintegrated, the shuttle tumbled, and that was the end of it. Looking at the boldface language in this article in the New York Times, damage to the Space Shuttle Columbia's wings was so subtle. Chaos, butterfly effect. The administrator was sobered by the minuscule size of breaches in the leading edge of a test wing. Down at the bottom, next to the left, pictures of the test wing showed hairline cracks ranging from about 1 inch to 6 inches long. You've got to put your face 2 or 3 inches away to see the crack, he said. They were very, very small. And here's what happened, and this is really interesting, is that they were talking about what was going to happen, talking about what to do. And so engineers put together a PowerPoint presentation to present to NASA about what the damage had been. And here's kind of the lesson that we learned from this. Typing text on a screen and reading it out loud does not count as teaching as I read it out loud. An audience reading text off the screen does not count as learning. Imagine if the engineers had put up a slide with just foam strike more than 600 times bigger than test data. Instead, they put this slide up, and you'll see what is on the bottom there in red. Flight condition is significantly outside of test database. Volume of ramp is 1,920 cubic inches versus 3 cubic inches for test. That didn't mean anything significant to anybody. It was at the bottom. It was ignorable. It didn't make all that much sense. If you really thought about it, you're like, wow, that's a big difference. But what happened was that they tested the wing before they had them re-enter, but the test was 600 times less energetic than what had actually happened to the wing on the shuttle. And this is text here, and there's a bunch of chaos language in here, but I'm going to go down to the bottom where it says, they estimate that during the launching, the debris was rotating about 18 times a second, so they have no idea how it hits. It was all chaotic. They didn't know where it came off, how it hit, they just couldn't figure out, they couldn't backwards engineer the thing at all. And they were a little bit, well, we better say a lot misled by the way that a slide was put together. So there's a number of levels of butterflies flapping their wings for the Columbia. All right, let me check our time here. Lynn, what should we do? Want me to go through real quickly, or is this a good place to stop?
Andy, why don't you go ahead and do a little wrap up for us? I've got a couple of questions for you.
All right, let me do this. Let me go through this as quickly as I can. Blah, 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 blah. I've got maybe 100 slides on climate change, but they're all blocked out, but a few of them right now. Earth at the tipping point. This was Time Magazine back in 2006. They just had another special issue on global warming to see how they did. Things are more radical, that their predictions are far short of what they thought they were going to be. And it's all chaos. 1% of 1% change in the Earth's atmosphere, 1 degree of temperature variation in the water. It was predicted as early as the 1970s. They had reliable climate models. Both the oil and coal industry were well aware back in the 70s, but they didn't tell anybody. They launched a campaign to sow doubts about climate change, and that's where that came from. Executives at Shell knew decades ago that burning fossil fuels would cause the planet to warm. Last year, the writer of this article sat down with Van Borden for a wide-ranging interview and asked him how he felt about Shell Knew, the activist mantra that accused the company of failing to act on climate change. He was sanguine. Yes, we knew, everybody knew, and somehow we all ignored it. In the 1990s, Shell publicly acknowledged climate science, said the world needed to act, but at the time, neither governments nor consumers were too concerned. Demand for oil was growing, so they just produced and sold oil for a profit, and there we are. I had a guy argue that not a single climate model had been able to make an accurate prediction, and therefore it was not science. I was a bit curious about this and found some interesting studies. The upshot that was, while 25% of models older than 20 years had overestimated the warming, fully 75% had underestimated it. Aha, gotcha, said he. See, they underestimated the warming, therefore the models were inaccurate, therefore climate change is not happening. Climate models have proven surprisingly correct. Critics, many of them mobilized by the fossil fuel industry, attacked those models as crude approximations of nature. As it turns out, they were wrong. The critique never completely died away. The models were surprisingly accurate. Even Exxon got the problem right. One of the graphs their researchers predicted with uncanny accuracy what the temperature and carbon dioxide concentration would be in 2019. 20-year-old predictions. We're getting dangerously close to climate tipping points. Climate change is happening much faster and stronger than we ever expected. We're all under threat. We must act now. These are headlines that I grabbed. Climate change could trigger huge drops in food production by 2100. 20 million have fled their homes due to climate change since '08. Airports are protecting themselves against rising seas. And these are headlines that I have grabbed from newspapers and the internet and magazines. Alaskan glaciers melting 100 times faster. Europe has 500-year storms in 15 years. Sea level should rise 20 meters. Global warming exceeds 2 degrees. Mont Blanc Glacier could collapse at any moment. Capitalism made this mess, and this mess will ruin capitalism. Sliver of the atmosphere is about to cause big problems on Earth. Germany has proven the modern automobile must die. Russian land of permafrost and mammoths is thawing. Siberian wildfires and heat waves in Alaska, how the Arctic is nearing a point of no return. Wildfires across Alaska and Siberia and Greenland. Power shut off to millions of Californians across 34 counties. The worst drought in 1,000 years in South Africa. In Louisiana, an island is already sinking and kids are losing their home. Arctic permafrost is thawing fast. Weather events are going to displace 143 million people by 2050. But rising seas are already threatening tiny tropical nations. The island that you see right there is an island that I've been to. It's called Kiribati, Fanning Island in the country of Kiribati. There's no place on the island that's higher than 10 feet above sea level. It's an atoll, and they are going to lose their island. Climate change and overfishing are making seafood more toxic. Climate warming responsible for the West Antarctic ice sheet melting. Global heating is exposing the Himalayas to pollutants and glacier ice. 200 abandoned ski resorts in the Italian Alps. First Icelandic glacier has melted. 11 billion tons of Greenland's ice melted on Thursday. I was actually in Greenland when that happened. And I was in Iceland when they claimed that the glacier was gone. At least 8 states could see their state birds largely disappear. Managed retreat isn't turning out the way we thought. 2/3 of birds in North America are at risk from climate change. Ocean's tipping point has been reached. 5 islands in the Pacific. Antarctica is being melted from the inside out. Climate change is a public health emergency, and the headlines go on and on and on. So if I can find my mouse. There, oh my, this is what happens. Okay, there we go. All right. All righty then.
Andy, thank you so much. Well, you brought back all kinds of memories for me of things that have happened to us for such crazy small reasons. We've got several interesting questions to discuss, and you get obviously the first shot at answering some of these. The first one's from Terry. He says, some people say that the problem is really a knowledge gap. In other words, we don't and can't know initial conditions to infinite precision. We don't collect data at every point. So do you think that's a valid explanation for the effect of chaos?
Well, it's something that I've thought and that I've other people have asked as well. And I guess the first part of it is to say that chaos is an established science. And so if that were true, then it wouldn't be. We wouldn't be talking about these things. The response could be at that point, well, okay, so we don't have complete knowledge, but it's possible to have. I have an atheist friend of mine, a young friend who I was talking to in England once, and he said, so really it is. It's just a question of if you could get enough information, then you could predict what's going to happen. And so it is just a problem of not having enough information. And I said, well, so here's the thing is that as the butterfly effect gets smaller and smaller, as the influences get smaller and smaller, then those things become harder and harder to find. And then he said, because he knows me and he knows what I talk about, then he said, oh yeah, then you get down to the quantum level and things are not predictable at all. So it's a continuum of an inability to predict at certain times, as we saw. Even at the quantum level, 95% of the time we can run pretty good models. It's that 5% of the time that throws everything for a loop. Just talking about what we're doing right now with coronavirus, we predicted that we were going to have a pandemic. We predicted that it was probably going to be, animal to human transmission, and it would probably happen in Asia. So you can predict those things based upon what's happened in the past. But what you can't predict is when and where and how bad and what kind of a virus it's going to be and how far it's going to reach and when it's going to dissipate. And so we are right in the middle of all that right now because of not being able to have access to full knowledge.
Okay.
What I said to my atheist friend, go ahead.
No, go ahead.
What I said to my atheist friends was, God can do all of those things, but we can't.
Yeah. There's a related question from Peter. It says anti-fragile systems, that's an interesting thought, improve when chaos happens. Example, our immune system improves when it's stressed. Chaos exposes fragile systems. So what can we do to build things or our lives to take chaos and actually become better versus just breaking?
Yeah. Well, I would be tempted to say that the U.S., I don't want to offend anybody here, but the U.S. has been exposed to have been a fragile system.
That's an interesting way to look at 2020.
Yeah. The U.S. was a fragile system. Were there things that we could have done? Yes, because we knew a pandemic was coming. But you have to have the will, you have to have the money, you have to have the foresight, you have to have the people who are able to enforce that kind of long-range planning with no specific time or disease in mind, but just to say, we're going to have a pandemic. Here's what we need to have in place. If we don't have it in place, it's going to be a mess, and we're not going to be able to react. But part of the way that we are a fragile system, and any country that has, that has politics is going to be the same way, is that politics and Western business have become primarily short-range thinkers. This is where China makes us look bad and Asia makes us look bad, because they are much better at long-range planning, at long-range thinking than we are. So we abandoned our long-range thinking with respect to pandemics, and so we find ourselves unprepared and unable to react in the way that we might have been able to. So sure, you can say it's coming, we don't know when or what it's going to be like, but there are things that we're going to do to protect it, to make the system less fragile.
Okay.
Now, what is likely to happen at some point after this is all over, if it ever is that some people are going to sit down and say, we have to prepare ourselves for the next time this is going to happen. And then in 10 years, they're all dead and the new people don't care.
Okay. Here's another one for you. This is from Greg Jackson. Greg, you may need to have to explain this a little bit for me. He says, chaos implies that omniscience is the only way to see the future. Do you see any theological implications in this? Greg, what exactly do you mean by omniscience?
Omniscience.
Oh, omniscience.
Omniscience.
Oh.
Okay. All right. Read it again with the word omniscience in the middle. Then.
Sorry. Chaos implies that omniscience is the only way to see the future. Do you see any theological implications in this?
Well, clearly I would. One of the books that I wrote is called Quantum God, Fractal Jesus. But inside the book, I say that God is, the God that we have is not a Newtonian God. He's a relativistic, quantum, chaotic, complex God, referring to both chaos theory and complexity theory. So he is the God of chaos. And if you look at both Scripture and our interaction with Scripture, what we tend to do very strongly is to emphasize the God of order rather than the God of chaos. What the God of order is all about is health, wealth, and prosperity, is taking care of me and my needs, healing me of my diseases, keeping me from having bad bosses and bad jobs and all the rest of it. That I reduce God to being somebody who's all about me and my personal concern. But about half the Old Testament is not prosperity theology, it's disaster theology. Because the people of Israel, when they did not obey God, were taken into disaster. And it's tragic, it's frighteningly informative to look at what's going on right now, to look at what happened to the people of Israel when they did not obey God in the way that he commanded them to do so. They were taken into captivity for what, 400 years? And many people died, and the people who died, it didn't seem as though God was picking and choosing and saying, you get to live and you get to die. It was kind of a mass slaughter. And I don't think it's too much of a stretch to say that that's what we're watching right now. In one sense, we're watching a slaughter. We're watching people die of all ages and all ethnicities. And yeah, it's more focused in old people, weak people, sick people, poor people. But it's chaos. We don't know what the future holds and where it's going to go. Had I been able to get into I put together a COVID-19 talk today, and in the Washington Post today, they said that scientists are moving to a place where they think there are super spreaders, that about 10% of the people who are affected with COVID-19 are super spreaders, about another 10% are moderate spreaders, and then about 80% hardly spread it at all, but that these super spreaders tend to be young, asymptomatic, and social. So you think about that, and that's kind of a scary thing, because those are the people out wandering around the streets.
People, Carrie and I and others will be teaching next year, this fall.
Yeah, that's right, and me as well. So I truly believe that God is a God both of chaos and of that he brings new order out of chaos in creative and unpredictable. Complexity theory is another talk that I do, and that's where order arises out of chaos unpredictably. And that sounds very much like a God thing to me.
Could it be that this unpredictability is part of prayers being answered? In other words, everything not is in order. People say, how can you pray and ask God to change laws of nature? If everything is so complex and there's so much uncertainty, then prayer does affect things. In other words, God being omniscient can be involved in that unpredictability aspect. Yeah.
Yeah, and I can give you the perfect example of God using the butterfly effect to change the history of time. He used a tiny little baby in a backwater country and a no account race of people to save us all.
Mm-hmm.
That's chaos right there. That's the butterfly effect right there. Who would have thought that a little baby born to an unmarried girl in Palestine, 2020 years ago, would have the impact that baby had. So as I think about God, and I always want to be careful not to tell God how to do his business. But it seems to me that if you remember that verse in the Old Testament where it's something like, I listened for God in the storm and I didn't hear him, and I listened for him in the earthquake and I didn't hear him, but I heard him. I heard him in the still small voice. That God was the still small voice, and I've butchered that verse, but it was the still small voice that is that butterfly effect. It's that God reaching out in a moment in a tiny way with a little nudge or a push to make things happen beyond our ability to predict or control. And I think prayer has a role to play. Now, why would one person's prayer affect the God of the universe? And yet it seems that it does. So yeah, that's a good insight.
Yeah, prayer does not have to do necessarily with precision laws. These chaotic laws leave a lot of freedom for for God to act without changing, quote unquote, the laws of nature. So a scientist can pray and expect his prayer to be answered with changes happening. That's my point.
Yeah, and God is chaotic. He doesn't answer all of our prayers, and he doesn't answer them in the way that we want him to. He answers them chaotically, and you could say, well, that's just a lame explanation for there not being a God at all, and your prayer, you know, sometimes you get lucky and life turns out the way you wanted to, and then you say, oh, God answered my prayer. And sure, you can say that, but you know, I believe in God. I believe in the still small voice of God. I believe that God listens to our prayers, and I believe that God does exactly what he wants to do, but that he involves us. We are the butterflies. We are the small effects. I mean, God will use each one of us as the flapping of a butterfly's wing to affect huge changes in the building of his kingdom, in ways that we can't predict or control. We are each that tiny little moment in history that God chooses to use in unpredictable ways.
All right, Andy, I want to take you from the big picture and the grand theologies to a technical question.
Sure.
You remember the avalanche slide, or slides? The end of your section on the avalanche, the scientist was saying, well, now we can look within the cells of the snowpack or something, and we can predict better. Do you know anything about that change of technology, about snow science?
But it's a little bit like the change in weather predicting, that we get better at it, but we still, you know, weather predicting is now out to about 9 days or maybe 2 weeks, but not much further. Avalanche prediction is better than it used to be, and yet people get caught in avalanches all the time. Why does that happen? Well, most of the time is because nobody was up on this particular slope checking it out. There's a certain, you know, it's about 35 degrees or thereabouts, you know, in a chaotic sort of way. There have to be snow conditions, usually a hard pack on the bottom and a heavier, lighter layer on the top. And then the temperature has to be about what it's supposed to be, and you have to have melting happening. So there's all these types of things. So yeah, we're better at predicting avalanches than we used to be, and yet we still kill about 9 people every year in avalanches in Colorado. And you know, we don't send snow scientists up onto every mountain to look at every snowpack. We send ski patrol up there with explosives, and they hope to be standing in the right spot when they shoot their mortars into the snow, based upon the knowledge that they've gained over the years. But every now and then, I think last year, the year before, one of them got swept away in his own avalanche. And killed.
Yeah,
It's
Lynn is right.
yeah.
The general laws improve, but that doesn't mean that the specific system can be predicted. That's what you're trying to say, correct?
Yeah, that's right. Lynn, you're muted.
We have one more question in the chat line that's a slightly different, that's a bit off topic, as Rob says. So before I go to that one, does anybody online here, would you like to entertain a question related to chaos theory? Okay, sounds to me like we've scratched our itches, so to speak.
The fact that we use theory, to me, says that it's not totally random. Theory means you can do certain things with it. You can predict generically, sometimes broadly, sometimes not so. That's why I like the word theory. Chaos means complete unpredictability. You know, it's you see what I'm trying to say? Theory means there's something in there that you can intelligently work with. Correct?
Yeah, and I think the problem, as I see, and this is kind of my own opinion, but I'm fond of it, is that we confuse the word random with the word unpredictability.
Mm-hmm.
That they're two different things. Random, you know, we could go around and around about randomness. Unpredictability is something we understand. Just because Things are occasionally unpredictable in radical ways, but they are often predictable in predictable ways. The question is where the line is drawn between predictability and unpredictability that chaos comes into play.
So just, I put an entry in the chat. This, again, it's part of that sort of 80s and 90s books and studies on chaos and complexity that there was a lot of chat about that. But this book, How Nature Works by Pierre Bach, I don't know if you've seen that. That's the sand pile studies. So, you know, just like in the avalanches, but you can't predict a particular event, but you know from the dynamics of the system that there's, you know, likely to be an event, or, you know, and there's the power laws that relate to it and things like that. And so there are ways of describing these events, even though we can't predict them in any kind of exact way.
Correct. Yeah.
Okay, hang on just a second. I got one new message. We'll get back to that one. This is from Rob Gibson, slightly off topic, but I bet you we can get some answers for him among the people on the call here. He says, these questions are off topic, but I'm considering including answers to these questions in my upcoming talk on climate change. So here's the question. What is a good book or source of information on Malthusian thought in the environmental movement and the climate change movement from a Christian perspective? What would be a good Christian response to these Malthusian thoughts in these movements? Takes me back to the, what was it, the second one we did? Was on the Planet of the Humans video. At any rate, Ken, Terry, I know some of the other ones on the call are avid readers about such things.
I'll just mention this. It's a brand new book. It's called Apocalypse Never by Michael Schellenberger, who's you know, lifelong environmentalist activist, but is writing about how some of the attitudes of environmentalists have actually backfired on us, and one of them is sort of a Malthusian view of the world, and you know, it's a very interesting book. He's an interesting character. He's part of a group of people that I call pro-nuclear environmentalists. It's kind of two things come together there that you don't expect. But you know, it's very much a pro-humanist perspective that he brings, and he is providing example after example of ways that environmentalist policy has actually led to bad things happening for local population, or anyway, it's not exactly a Christian perspective, so that's not exactly what you're asking for, but I think some of the themes that you might be getting at there come out in that book.
All right. Rob, I'm going to do a little bit of research about your question myself. I might bounce it off of Catherine Hayhoe. She has a small book of her own, but I'm sure that there's some other ones we can recommend as well. So if we can get anything else, we'll get it back to you. Any other questions? I have one little goodbye here. It says, thanks, Andy, for, oh, everybody got this one. Sounds like Greg is getting off. Good to see everyone, hope face to face. Blessings to all, okay. Any more questions on the topic? Because if not, it's 8:28, which is just about where I thought we'd be right about now. And I'd be happy to kind of move us into, kind of sharing mode.